If you don't choose, I will. I'm going to choose 21. In 21, we have a sub n, the general term, which is 2, n plus 1 factorial. And they want the same thing. Write the first 4 terms. Nothing difficult. I have to find A1, I have to find A2, I have to find A3, and I have to find A4. What does this mean? When n is 1, 1 plus 1 is 2. So then I have 2 times 2 factorial, which is 2 times 1, which is 2. So the first term is 4. The second term, I have to copy 2 times 2 plus 1 is 3. 3 factorial is 3 times 2 times 1, which is 3 times 4, which is 12. A sub 3, 2. 3 plus 1, and that is 4. 4 factorial is 4 times 3 times 2. There is no point in writing times 1. So 2 times 4 is 8, 3 times 2 is 6. 6 times 8, 48. Last one, 2 times 5 factorial. But 5 factorial is 48 times 5. Well, let's write it out. 2 times 5 times 4 times 3 times 2 times 1. Okay, so this is 10. And this is 6 times 4, 24. 24 times 10, 240. So what are the first 4 terms of this sequence? They are 4, 12, 48, and 240, ... But we're only asked to present the first 4. Is this clear? Any difficulty here? Any questions?
No, no questions.
Okay. So now finally, let's talk about this eluding summation notation. Summation notation. Others call it sigma notation. Same thing. Summation notation or sigma. What is the sigma? It's the Greek letter S, which is extremely convenient and useful for what we need. It's S, but it's the Greek S. And it's called sigma. That's the name of this letter. It's a Greek letter, but it really represents the summation, sum, or S. Why is this convenient? Because it has a big base, if you see it here, and I can say from I equals 1 to 10, let's say, as an example, from AI. What is all this? What does this mean? Remember, a sum. We're talking about sum. This sigma notation or summation notation represents a sum of terms. So how do I write this out? When I is 1, A1. The sum says plus. When I is 2, A2. When I is 3, A3, plus. Exactly 3 dots, another plus sign, and when I is 10, I'm done. We don't like this notation because this one is very convenient. What if I have 100 terms where I'm going to list 100 terms? No. I'm going to write the sum. This is called the index. From the index being 1 till the index 100. From AI. A sub 1 plus A sub 2, plus A 100. This is the condensed notation of all this. Okay. What if I am asked to calculate this? Calculate from I equals 1 to 7, I plus 3 times I minus 2. What does this mean? Okay, it means this. When I is 1, 1 plus 3, 4, 1 minus 2, negative 1, plus. When I is 2, 5 times 0, plus. When I is 3, 3 plus 3, 6, 3 minus 2 is 1, plus. So times 1 if you want, plus. When I is 4, 4 plus 3, 7, 4 minus 2, 2, plus. When I is 5, 8, 5 minus 2 is 3, plus. When I is 6, 9 times 4, plus. Finally, I got to 7. This is the lower limit. This is the upper limit. That's it. That's where I have to stop. So 7 plus 3 is 10, multiplied by 7 minus 2, which is 5. I'm going to calculate all these terms. This is negative 4. This is 0. This is 6. This is 14. This is 24 plus. This is 36, and this is 50. So this is 20. This is 20. So 20 plus 20 is 40. 40 plus 50 is 90. Plus 36, I got 126. So what does this mean? The sum of the product of these factors from I equals 1 through 7 is 126. Is there a nicer way to calculate this? Yes. Of course there is, and here it is. In math, scroll up, here it is, summation notation. So all I have to choose is 0. And I have to use x because there is no I in the calculator. So from x equals 1 till x equals 7. And careful, in parentheses I have to have x plus 3. Separate parentheses from what you see the whole thing comes with. Okay? Times, or just simply parentheses, x minus 2. And when I click enter, I better get 126. If not, I have to go back and check my calculations. Okay? So I will ask you to just write out the terms, and you don't have to calculate this. You just, I wanted to go through it because it's right here. I had to do it. And just put the answer with the calculator. But I want you to present the terms. So when I is 1, 4 times negative 1. When I is 2, 5 times 0, and so on and so forth. Write out the terms, and then the calculations can be done with the calculator. That's fine. So this is the concept of summation notation. Let's look at other examples. So let's look, for example, at, I don't know, 39. You choose the next one. 39, the sum from I equals 0 to 4, from negative 1 to power I. So the indices can be I, J, or K. So don't get upset if you see I, or don't get startled that it's K and it's J. No, it can be anything. Okay, so from I equals 0 to 4, from negative 1 raised to I over I factorial. Yes, I can put this in the calculator, but let's just present the terms. Okay. When I is 0, negative 1 to 0 is 1 over 0 factorial, which we know it's not 0, but it's 1. The sum says plus. When I is 1, negative 1 over 1 factorial, plus. When I is 2, Negative 1 to the second power is 1 over 2 factorial plus when I is 3. Negative 1 to the third power is negative 1 over 3 factorial plus finally when I is 4. 0, 1, 2, 3, 4, and I have to stop. Negative 1 to the fourth power is 1 over 4 factorial. Okay, I presented the terms, and now I can find the answer with the graphing calculator. I don't want you to spend time calculating this. So, again, careful how you enter it. Okay, so it starts at 0, and it goes to 4. From 0 to 4. And now, we have, in parentheses, negative 1 to power x. And the whole thing come down and divide by x. And now the factorial symbol is under math and probabilities. That's number 4. And that's it. So the answer is 0.375. So we determine the sum. What sum? The sum of these 5 terms. Not more. That's it. From I equals 0 to 4. This is a very convenient way of writing this. Very condensed. Any questions? Any questions? Okay, now let's look at the reverse situation. What do I mean by the reverse situation? I mean, I'm given something like this, and they are saying, they're asking us, write the summation. I don't want to see a chain of numbers, a sum of numbers like that. I want you to condense it. Okay, so let's condense it. So let's start with 43. In 43, we have 1 squared plus 2 squared plus 3 squared plus exactly 3 dots plus 15 squared. Okay, so this has to be condensed using the sigma notation. So from I equals, you tell me what, till what, and what do I have here? Let's give it a shot. It looks difficult, but just think and tell me what you would write.
Will the base be 2?
You mean the lower limit?
Yes.
But if I put 2 here, how will I get 1 squared?
Is the lower limit 1 and the upper limit is 15?
That's it. From I equals 1, from I equals 2, I equals 3, dot, dot, dot. Now, let's see how this term looks like so I can get each and every one of them. When I is 1, I want to get this. When I is 2, I want to get this. When I is 3, I want to get this. Any suggestions?
Is it just I squared?
That's it. There is nothing else. When I is 1, I get 1 squared. When I is 2, plus 2 squared. When I is 3, plus 3 squared. When I is 4, plus 4 squared, dot, 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 dot. When I is 15, I get 15 squared. That's it. Excellent. Okay, let's look at another. Okay, let's look at 50. In 50, we have 1/3 plus 2/4 plus 3/5 plus dot 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 plus 16 over 16 plus 2. Okay, let's see how we come up with this one. Let's start with the numerator. The numerator tells us where do we start. Let's use J this time so we can get used to J as well, and K, it doesn't matter. And of course, it must be a fraction because we have all of them are fractions. So let's start with the with the numerator and see what we have here, what we have here, what we have here.
Is the lower limit 1 and the upper limit is 16?
No worries, of course, clear. So what do I have here? So that I get when I is 1, I get 1. When I is 2, I get 2. When I is 3, I get 3. When I is 16, I get 16. J, I'm sorry. Give it a shot. It's okay if you're wrong.
Is it I over
Sure.
I plus 2
Exactly.
or J plus 2, sorry?
Exactly the same thing. It doesn't matter. Exactly. When I is 1, 1 over 1 plus 2. When I is 2, 2 over 2 plus 2. And you can see it here very clearly. This must be I, this must be I, and this is, oh, J, and J plus 2. Excellent. Okay, let's try one more. Okay, let's look at 51. 4 plus 4 squared over 2 plus 4 cubed over 3 plus 3 dots plus 4 to the nth power over n. Now we know that the last one is n because that's what it is. So let's use k this time. Of course, you have to imagine that there is a 1 here, of course. So, what do you think? What do we have in the denominator? And where does it start? Where does k start?
Would it be at 1?
Say it again. You said 1?
Would it be 1?
Correct. When k is 1, I have 1. When k is 2, I have 2. When k is 3, I have 3. When k is n, I have n. Good. Now let's decide upon the numerator. So this must be k. What about the numerator?
Would it be 4 to the power of I over I?
Yes.
Or K?
Same thing. If you want to use I equals 1 to n, 4 to I over I. Since we used k, I'm using k. It's exactly the same. The index is your choice. But as I said, we normally use I, J, or K. Can you use A or B? Yes, anything. As long as you say the sum from B equals 1 to n, from 4 to B over B, that's fine. Everybody will understand. This is it. There is nothing else. This is the end of the course. There is nothing else that we need to go through. We covered it all. I like to go back to Gauss-Jordan. How do you feel about that?